Late 1943. An Eastman Kodak engineer stared at the specifications from the Office of Strategic Services. Build a camera small enough to hide in a matchbox. Make it photograph documents without arousing suspicion. Ensure it works in the hands of agents who had never used a camera, and deliver it in 4 months. The engineer thought it was impossible. It was not. By early 1944, Kodak delivered 500 cameras that fit inside matchboxes. Each one could photograph 34 documents on a single strip of film. Each one looked like an ordinary box of Swedish or Japanese matches. And each one gave American agents the ability to steal German military secrets in seconds while standing at an officer's desk during casual conversation. The problem was document photography. Resistance networks needed to photograph German documents, but existing cameras were too large. A Leica measured over 4 inches and weighed several pounds. Guards searched everything. Carrying a camera meant execution. The OSS specifications seemed impossible. Create a camera under 2.5 inches long. Make it hold 30+ exposures. Photograph documents from 4 feet away. Design controls operable by touch in darkness. Eastman Kodak assigned the project to their Special Products Division in Rochester, New York. The team began with the film format. Standard 35mm film was too wide. They selected 16mm film, the same stock used in home movie cameras. A 2-foot strip of 16mm film could hold 34 individual frames measuring 14mm square. This gave agents enough capacity to photograph an entire briefing document or technical manual on a single load. The camera body presented the next challenge. It had to be rigid enough to keep the film plane flat and the lens properly aligned, yet small enough to fit matchbox dimensions. The engineers chose bakelite, a hard plastic material that could be molded to precise tolerances. The bakelite inner body contained the film chambers, the advancing mechanism, and the shutter assembly. This entire unit slid into a metal outer sleeve that measured 60mm long by 38mm wide by 22mm tall. The lens was critical. At such close focusing distances, any optical imperfection would blur the image beyond readability. Kodak selected a 25mm Tessar type lens with an aperture of f5. The fixed focus design eliminated moving parts that could jam or break. The engineers set the focal range from 4.5 feet to infinity, the exact distance an agent would stand from a desk while conversing with a German officer. The aperture could be adjusted to f8 using a small pin accessible on the camera body. This allowed agents to compensate for different lighting conditions. In bright office lighting, f8 provided sufficient depth of field. In dimmer conditions, the wider f5 aperture captured enough light for readable images. The shutter offered 2 settings, 1/60th of a second for normal exposures and bulb mode for longer-timed exposures in low light. The film advancing mechanism required particular ingenuity. The camera had no viewfinder, no frame counter, no visible indication of how many exposures remained. Agents needed to advance the film by feel alone, often while maintaining conversation and eye contact with a target. The engineers designed a winding wheel that protruded slightly from the smaller side of the camera. The wheel had 2 tactile marks positioned exactly 180 degrees apart. An agent could feel these marks through fabric, advance the film 1 frame, and prepare for the next exposure without looking down. The shutter release was equally clever. A small button on the same side as the film advance allowed single-handed operation. An agent could palm the camera, advance the film with thumb movement, and trigger the shutter with finger pressure, all while the camera remained concealed in a closed fist or coat pocket. The entire operation took less than 3 seconds per frame. Kodak delivered 500 cameras in early 1944 with complete kits, including film, developing chemicals, spoon, agitating stick, chamois cloth, and film clips. Agents could develop film in any hotel bathroom with a drinking glass and water. The cameras included a document copying stand with close-up lens. This held the camera at optimal distance above documents. An agent could photograph entire pages in 5 seconds each. The outer disguise varied by mission. Some cameras received Swedish Matchbox labels. Others got Japanese match company markings. Some arrived with plain metal finishes for agents to customize based on their operational area. The label application was meticulous. Kodak printed the labels on authentic paper stock, aged them appropriately, and applied them with period-correct adhesives. A German guard inspecting the Matchbox would see printing, typography, and materials identical to locally sold matches. The operational deployment began in mid-1944. OSS stations in London, Bern, and Stockholm distributed cameras to field agents and resistance contacts across occupied Europe. The cameras went to agents infiltrating German headquarters, to resistance members in railway offices, to partisans photographing defensive positions. Each recipient received minimal instruction. Load film. Advance wheel after each exposure. Press button to photograph. Process with provided chemicals. Combat effectiveness proved immediate. An OSS agent in France photographed German defensive maps during a meeting with an occupation official. The agent stood across the desk, engaged the officer in conversation about supply requisitions, and photographed 4 maps while the German reviewed paperwork. The entire operation took 6 minutes. The developed photographs showed every defensive position, minefield location, and artillery emplacement along a 15-kilometer sector of the Atlantic Wall. Allied planners used these photographs to identify weak points and plan breakthrough operations. In Belgium, a resistance member working as a cleaning woman photographed German communications logs. She carried the camera disguised as Belgian matches in her apron pocket. While cleaning the communications office at night, she photographed 2 weeks of radio traffic logs, encoding procedures, and frequency assignments. The intelligence reached London within 48 hours. Allied codebreakers used the captured procedures to decrypt German military communications across the entire Western Front. The breakthrough revealed German unit movements, supply status, and defensive planning. A network in Denmark used 3 cameras to photograph German shipping manifests at Copenhagen Harbor. Resistance members employed at the port office had access to cargo documents showing every transport heading to Norway and Germany. Over 6 months, they photographed manifests for over 400 shipments. The intelligence detailed German supply shortages, revealed which factories were receiving raw materials, and showed exactly where critical resources were being allocated. British naval intelligence used this data to prioritize submarine attacks on the most valuable cargo vessels. In Norway, agents photographed German coastal defense blueprints. The documents showed gun emplacements, ammunition storage, fire control positions, and range cards for every battery defending Trondheim Harbor. The photographs enabled Allied naval forces to plan precision bombardments that neutralized the defenses before amphibious operations. German defenders never determined how their secret defensive plans had been compromised. The camera's reliability under field conditions exceeded expectations. Agents operated cameras in freezing Norwegian winters and humid French summers. They photographed documents in dim basement archives and brightly lit offices. They reloaded film while hiding in closets, bathroom stalls, and storage rooms. The bakelite construction proved durable. The simple mechanical design required no maintenance. Units photographed thousands of documents without mechanical failure. The technical specifications gave decisive advantage. At 60 by 38 by 22 millimeters, it was smaller than a cigarette pack. German Minox cameras measured 98 millimeters, over 50% larger. British subminiature cameras averaged 70 to 80 millimeters. The American camera weighed 100 grams, less than half the weight of German equivalents. Production quality set American engineering apart. Kodak manufactured to precision tolerances using industrial methods. German cameras suffered chronic quality problems from material shortages. British cameras showed similar inconsistencies. The American camera performed flawlessly. The strategic impact was measurable and significant. Between mid-1944 and May 1945, OSS agents and resistance networks using Matchbox cameras photographed an estimated 15,000 pages of German documents. This intelligence included defensive positions, supply manifests, troop movements, technical specifications, and communication procedures. The photographs contributed directly to Allied operational planning for the invasion of France, the advance through Belgium, and the final push into Germany. The intelligence value exceeded the cost by orders of magnitude. Each camera cost approximately $250 to manufacture and equip. The intelligence each camera generated prevented Allied casualties, identified strategic targets, and accelerated military operations. A single camera in Denmark photographing shipping manifests enabled submarine attacks that sank cargo vessels worth millions of dollars. Another camera in France photographing Atlantic Wall defenses saved hundreds of Allied lives during breakthrough operations. Post-war validation confirmed American technological superiority. The Soviet Union captured several Matchbox cameras from German counterintelligence files and attempted to reverse engineer them. Soviet efforts failed to match Kodak's optical quality or mechanical precision. The cameras entered CIA service after the war and remained in operational use through the early 1950s. Several Allied intelligence services requested American Matchbox cameras rather than developing indigenous alternatives. The weapon's legacy extended beyond World War II. Modern subminiature camera design traces directly to the Matchbox camera's innovations. The concept of document copying cameras, small enough to conceal in everyday objects, became standard across intelligence agencies worldwide. The Matchbox camera proved that American engineering could miniaturize complex optical systems without sacrificing functionality, a capability Soviet and European manufacturers could not replicate. Kodak produced approximately 1,000 Matchbox cameras between 1944 and 1945. 500 units delivered in the first batch, 500 in the second production run. This limited production reflected the camera's highly classified nature and the specialized training required for operational deployment. Each camera cost the government approximately $250, equivalent to nearly $4,000 today. The investment paid for itself thousands of times over in intelligence value. The Matchbox camera represented American innovation under pressure. Engineers solved problems other nations could not solve. They created a camera smaller than anything previously attempted. They made it functional, reliable, and simple enough for untrained resistance fighters to operate successfully. They delivered it on schedule despite wartime production constraints. And they proved once again that American technological superiority was not accident or luck, but the result of engineering excellence applied to seemingly impossible requirements. 60 millimeters long, 38 millimeters wide, 22 millimeters tall, 34 exposures, 4.5 feet minimum focus distance, 1/60th second shutter speed. These numbers defined the camera that photographed German secrets across occupied Europe. The camera disguised as matches. The camera guards never suspected. The camera that proved American engineering could hide devastating capability in an object small enough to fit in a shirt pocket.